Hi, good morning, everyone. This is Nicole Testa-Boston, the Deputy Director at FIATech, and we're really glad you could join us on this Tuesday morning to hear from one of our FIATech members, IntelliWave Technologies, about their field progressing using RFID and mobile devices. Before we go ahead and get started and I introduce our speaker today, I did want to go through a few housekeeping items. You will notice that your GoToMeeting toolbar is unique to you. You can minimize that by clicking that orange arrow at the top. You'll also have noticed that you are on a defaulted mute setting due to the number of attendees on this call. So we do ask, though, and appreciate your participation and input, and you can do so by using the Questions tab on that toolbar. So at any time during the presentation, if you've got a point you'd like further clarification on or a question you'd like to ask, just type it in there. Those will go directly to me. And at the end of Dale's presentation, I will facilitate a Q&A with him. If we run out of time or if your question requires a more detailed explanation, we will forward those on to IntellaWave, and they will follow up with you after the webinar. We also will be recording this webinar. We'll be taking both the slides and the audio and providing a link on our FIATech page under Events, and then under Events, it's under Webinars. Give us a day or two to get that packaged and posted, but then that's something that you can share with others as well. And last but not least, I want to remind everyone that the FIATech Technology Conference and Showcase is coming up in about 7 weeks. We're going to be down at the JW Marriott in the Hill Country north of San Antonio, March 25th, 26th, and 27th. We've just confirmed most of the speakers, and we'll have the full program online hopefully later today. But we hope all of you will be able to make it, and if you haven't had a chance to see what's going on, please go to our website. You can click from our home page onto the conference page and take a look at all the speakers, folks who are registered, our exhibitors and sponsors, and register straight from that site. So with that, let me go ahead and introduce Dale Beard. At IntelliWave Technologies, Dale works directly with end users to understand solution requirements to help deliver value in addressing common pain points for material, equipment, and personnel management on large industrial construction projects. Prior to co-founding IntelliWave in 2007, Dale was a product manager for Agilent Technologies in the Signal Analysis Division for 4 years located in Santa Rosa, California. As a product manager, Dale helped to understand customer requirements, lead new product launches, and train the worldwide sales force on the latest RF test equipment used for manufacturing devices with 3 4G cellular, Bluetooth, Zigbee, and Wi-Fi technologies. Dale spent the next 3 years in Seattle, Washington as a product planner and product manager for the Fluke Corporation, working in the Precision Measurement Division. At Fluke, Dale was instrumental in determining product requirements and managing remote teams around the world to deliver new calibrator instruments into the market for electrical and RF measurements. Dale received a Bachelor of Science in Electrical Engineering with honors in 2000 from the University of British Columbia and an MBA from the Foster School of Business at the University of Washington in 2007. He's currently registered as an active member of the Association of Professional Engineers and Geoscientists of Alberta, and is joining us today from a very cold and windy Newfoundland. So welcome, Dale. Thank you for making the time, and let's go ahead and get started.
Thanks, Nicole. First, I want to say thank you, everyone, for joining the FIATech webinar today. I'm happy to present some of the latest technologies we've been working on at IntelliWave Technologies. And as Nicole mentioned, I am at a client site today in Newfoundland at a mine site. So if there's a little bit of wind noise in the background, please disregard that a little bit. It is about 40 knots here, gusting 40 knots, and so sort of a windy, cold day in Newfoundland on the rock. But yeah, I'm going to go through my slides here and kind of, like I said, show you the latest in technology that we're working on. And then at the end, please, feel free to ask some questions. I'm planning to present about 40 minutes of information here, and so I'm hoping to give you about 20 minutes of Q&A time at the end. So I want to start off the presentation with a safety moment first here. It is winter in most of North America. Here, and if you're calling from somewhere in the south of the equator, you may not see this, but for winter driving, especially in Alberta, where it's very cold, windy, snowy, icy. This is actually a photo from the highway going from Edmonton to Calgary. So you can see the snowing blowing across the road there. That's a typical winter. We're going to get down to about minus 40 Celsius or so in the winter. And so with winter driving, you really need to be careful in terms of making sure you don't get stranded out in somewhere where you could freeze to death, because that does happen once in a while. But if it does, you need to make sure you're prepared. You just take warm blankets with you when you go driving. Make sure you have a kit in case you break down, so a shovel to get the snow out of the way, or sand to help with traction. One of the biggest things with winter driving, though, is probably skidding off the road or sliding off the road into the snowbank. And if that happens, you can roll your vehicle fairly easily. And so to stop against that, one of the biggest rules to learn with winter driving is really to not drive with your cruise control on. If you are driving with your cruise control, you can easily slip the rear wheels of your car if you come across an icy surface, and that does relate back to a lot of sliding off the road into the ditch, which then creates rollovers and accidents. So just in mind when you're coming to Alberta or anywhere cold in the world, just make sure to keep your safe distance, drive slowly, and don't drive on cruise control. So a little bit about IntellaWave Technologies. We might be a new company to some of the folks dialing in here today. As a company, we really emanated from the needs of the users, and we started our company back in 2007 based out of Edmonton, Alberta, working with a large contractor, really based doing work in the oil sands and with pulp and paper and mining clients as well. And so what we did is we actually worked side by side, the contractor, for the first few years, where we understood the requirements of what it meant to have a hardened, robust system that we could use for tracking their construction materials, equipment, and also personnel. So since we started the company in 2007, we've really come a long way in terms of being able to offer a wide breadth of solutions focused around those three primary areas. And so what we've been able to do is really satisfy the technical requirements, but also the procedural requirements as well, being able to launch new technology into a construction environment where before a lot of the processes happening really were based on paper and pen and Excel and maybe some in-house systems. So we've been able to take that and really move that to the next generation of materials management and tracking, as well as tools and equipment tracking and personnel tracking. So what you're seeing here, this photo in the background, is a typical laydown yard. This was actually taken in Alberta. There's a little bit of snow in the background there, so not too much snow, but you can see there's a lot of material kind of all over the place, a little haphazard, I would say. And using RFID and GPS, you can really help understand, where is it and how do I go find it quickly to take to the work face. So a little bit about our IntellaWave SiteSense visibility platform here. We really started off, like I mentioned, in materials. So creating a tracking solution using RFID and GPS around material tracking for both on-site and off-site tracking. The next thing we moved into was site access and safety. So just to give you an example here, we're actually selling project sites now, integrated turnstile systems, like you can see here on the top here, integrated with different site access systems in order to do advanced muster calls on large project sites. So really we've been able to take some of the manual efforts of being able to muster a large site of up to 1,000 or 2,000 workers at a time and take that down to a matter of minutes in terms of being able to make sure everyone was accounted for in a timely manner. On the equipment and tool side, we also have an equipment module as well. So if you're tracking things like light stands and generators, welding machines, anything that can really move on your site, and you need to have that at the work face at a time when you need it to be able to be efficient in terms of getting the most time on tools, then really RFID and GPS is a great solution for understanding where those things are so they can be moved to the appropriate area at the right time. So the visibility platform actually goes from fabrication through supply chain and logistics on the construction site and then through maintenance. So as a company, we're actually involved in all 4 of these legs, being able to track materials as they come from fabrication, even through fabrication, even if you're looking to track progress of fabricated goods. And logistics, as an example, we have technology to track shipments like sea cans, vessels, anything that's fabricated that is really needs rigging on site. If you want to know exactly when it arrives on site to make sure your rigging crew is ready, then really you want a real-time tracking solution for that. And IntellaWave can provide a GPS-based solution so that you know exactly where your shipments are anywhere in the world. Once it gets to site, then integrated with our receiving procedures using handhelds and integrated with other material management systems, you can easily locate items as well in laydown yards and at the workface as well to understand the progress of those items all the way right through installation. And that's what we're going to cover today, is more on the construction side of how does it work for progressing using RFID and some of the mobile devices in the field. Now once all the pieces are installed and you come into a steady-state maintenance system, then really at that point RFID becomes valuable again in terms of making your plant a smart plant. So knowing where your equipment is and knowing what needs to be maintained. And RFID is a great technology for understanding some of those requirements that need to be done on a monthly or annual basis for your plant. So moving along here, just to talk a little bit about the visibility platform in terms of the hardware components. It really makes up sensor tags, handhelds, and different readers. So on the sensor tag side, you can use anything from barcode, passive RFID tags, active RFID tags, which give you a different benefit than passive RFID, and then GPS tags as well, which can be used to track shipments virtually anywhere in the world. So just to give you a little bit of a background on sensor tags here, you can select a sensor tag to meet the requirements for what you need to do. So for example, if you know you're tracking equipment on your project site and it moves around, so let's say it's a mechanical item or a pipe spool, and you really need to understand the location of that item on a daily basis or hourly basis, and really you want to use an active RFID tracking technology to do that using a infrastructure that can track RFID tags anywhere around your site. If you compare that to passive RFID as an example, passive RFID is great in being able to make sure that your identification bar is not going to get scratched off or that it lasts over time on your construction material. So you can easily scan a passive RFID tag and understand the attributes related to that material that you're tracking. It doesn't give you as good read range as an active RFID tag. So in that case, when you want to know material movement on an automated basis, passive RFID really is more of a manual tracking type tag for that situation that needs to be scanned by handheld or go through a really small portal where you can read it from a short range. Active RFID, on the other hand, can be read from up to about 300 meters. In some cases, we've seen tags being read much, much further than that, but with our rover system, the vehicle automated tracking system, we easily see tags being tracked from up to 1,000 feet away. On the handheld side, we actually have different handhelds, ruggedized handhelds, consumer-grade handhelds as well. The majority of handhelds that we deploy on project sites really are ruggedized, from Trimble handhelds to more tablet-type devices like this Juniper Mesa, as an example. It can run Windows mobile operating systems or Android operating systems, and so our sites and software can run on virtually any of those types of handhelds. On the reader side here, on the bottom right-hand side, you see a picture of a front-end loader. And so we've actually got a system that we call Rover, which is an integrated RFID reader with a rugged PC inside of it that actually operates in the background of the driver's daily duties. So as the driver is operating his loader, his skid steer, or front-end loader, whatever it might be. As long as that vehicle is turned on and driving, it's always collecting tag information, sending it back to the central server to understand the position of that material and whether or not it's moved. And so by deploying a number of these on your site, you actually get a fairly repeatable, I want to say, updating network that the RFID tags update their positions many, many times a day. And this can be over hundreds of acres on a site, and we've deployed many of these on trucks, front-end loaders, skid steers, and zoom booms. Also on the reader side, on the fixed reader side, you can use a fixed reader within a, this is a solar panel station that we have that really can operate autonomously. It doesn't require power, outside power. It also can come with cellular communications, satellite communications, or Wi-Fi. And so you can really just drop this down at a zone or a gate area and be able to receive materials automatically or tell if materials have moved into a zone. It's also really helpful for personnel tracking because these also duplicate as muster stations as well around your site to be able to read people as soon as they're mustered into a certain location. The other piece that I'll show you today as well are camera integration. And so if you're looking for visual verification on your remote sites, our system integrates with Sony iPellet cameras that can be accessed remotely and then can be used in terms of zooming in or panning around different areas of the project site to see in terms of progress what's the latest. On the web-based side, we actually have a SiteSense standalone feature here. If you're not integrating it into your already existing material management system, we do have a standalone web-based system that can be used for tracking materials, so positions of materials, progressing of materials, and much more. On the field mobile app side, we actually have a number of field mobile apps that work with the handhelds, and these can be anywhere from receiving items to locating items and to even progressing items in the field. And that's what we're going to cover here today. To go along with that, a large piece of what we do is actually integration into your existing systems. So we're not expecting to replace any of the systems that have already been being built for the last while with your company. We'll actually integrate and push or pull data as needed through some sophisticated integration. And so with that, on the personnel side, we've already done integration with a few systems, one of which being Linnell and Simply Safety, but also we can do integration on the contractor side as well if you have your own tools. Same with the equipment side. If you're using, let's say, Excel to track your equipment, like your billing daily rates, where your equipment is located, what you need to bill back to the client, then we also have modules for that as well. But we can also integrate with your existing systems too to provide information back to the reports. And specifically, if you need to provide where was the equipment on a certain day, we can push that data right into your system. On the materials management side, we've done integrations as well with other material management systems like FabTrack is one of those that provides tracking information for pipe spool fabrication. Intergraph Smart Plant Materials is another one. And then also specific EPC or contractor material management tools as well. So we have a sophisticated integration layer that allows us to easily hook into your existing systems to push that location and progressing data right into your systems. And so just move on there with progressing, the same thing as well. Your progressing systems can easily take data from our handheld integration side to be able to progress in the field and really push that to an earned value system like a tool such as Prevail. On the workplace planning side, we're also doing some really innovative integrations with workplace planning from Bentley's ConstructSim. Intergraph Smart Plant Construction is another one that we'll be working on here in the short future. And then Aviva REM as well will be another one. So let's get into the meat of the presentation in terms of how do you automate progress using handhelds and RFID. So first off, I just want to show you a couple overview slides on the results of what this all leads up to. So I'll give you the end of the presentation first, but what I'm showing here is we actually can progress systems based on construction work area, construction work packages, or even field installation work packages. And you can actually overlay your progress over a site image. In this particular screenshot, you're seeing it being overlaid on a satellite image. You can also do that on CAD drawings, site layout maps, pretty much anything you have that can be laid over a tiled system. And so in this case, each of these squares is representing, or the rectangles I should say, is representing a construction work package. And so as the progress gets completed, you visually see on your map, especially for a construction work area, how your progress is going along. So visually, it's becoming a tool that we've been using with some contractors in Alberta to be able to help progress their systems visually, to give a quick snapshot of their construction. So you can see here, where my mouse is, this particular construction work package is about 50% complete. And so you can see as it gets more completed, it fills up green until it becomes 100% complete. And I've actually overlaid that as well with a pin drop of a pipe spool as well. So the map is very easy to use, and because it is a web-based system, any user can log in from anywhere without having to load software on their computer to look at progressing it, as well as the where is it aspect of my material. Here's another look at automated progress, the end look of what you would see in terms of progress tracks. So we've actually got a patent pending around this progress track algorithm. But you can actually set up different progress tracks for different stages. So as you can see here, there are 3 different stages of the progress tracks that were set up by the end user. Fabrication track, so being able to know if you're building a pipe spool, for example, its progress on, if it's been cut, if it's been welded, if it's been gone through testing, so NDT testing or QC check. On the transport side, you can tell if it's been received on site, if it's in a laydown yard, and then if it's been issued to the work phase. So on the transport side, we actually automate the progressing, or can be automated through use of RFID or GPS movement. And so as the item is received on site, you automatically get awarded those points for it arriving on site. And if it goes into the laydown yard, let's say it's going into laydown A1 or A2 or whatever it might be, they can also add automated progress to that as well, just based on the movement of your tagged item. And so we'll go through some of these steps about how you set up these progress tracks, but either they can be set up based on material movement, or they can be based on field device updates. So as an example, on the installation phase, let's say you did something simple like a rigging phase, a bolting phase, and a testing phase. All of these can be updated directly in the field by really scanning the item and then selecting the next progress step that needs to be done, or has been done for that item, I should say. All right, so it's a pretty sophisticated system, and being able to leverage the latest in technology from sensor technology, sensor tracking technology, and handhelds working in the field. So let's kind of go through the different steps of how this works, because I'm sure a lot of you are asking, well, how do we get going on that? So the first step you want to do is really set up your zones for your material movement progress steps. And so we have geozone editors within the SiteFence tool. You can actually set up squares, rectangles, polygons, circles, basically anything you can imagine to manage your site area or zone. And so in this screenshot, you can see here there are a number of different laydown yards. There's a south laydown, a warehouse laydown, east laydown, a construction area, fabrication areas. So all this can be set up in order to determine when your material has moved into one of those zones. Your step 2 is setting up your material movement to trigger on the material movement. So as an example here, there's a configuration manager that's pretty easy to use. You set up your trigger as an example here. In this case, we're using a steel laydown as the trigger name. The description on this is update the progress of the steel when it enters this laydown area on site. So if you've received your steel and it now enters that site, you can automatically update that progress. for storage that it's now in storage essentially. So for that, all you need to do is really just select your location from a drop-down list of the zones you've just created, and then select the trigger type for that location. So in this case, we're selecting laydown as a general location to trigger that progress step, and then you just select that you want it to be triggered based on your progress update. Now you can also set up your progress step definitions as well. So before, when you saw those tracks, as an example, there was a cutting step in terms of being able to fabricate the pipe spool. So in this case, with that progress item for cutting, in this case we're going to set up as incremental progress, which means that you get weighted percentage to be awarded for cutting the raw materials to make the pipe spool. In that case, your progress method is going to be a calculation progress method. So this can relate back directly to fabrication tracking tools, such as IMS FabTrack would be one of those. But you can also use the website to do the same calculation methods as well. Okay, and so it's fairly flexible in terms of being able to set up different progress step definitions. Now let's say you want to set up your progress tracks and your values. All right, so in this step here, the progress item, the cutting progress item, and we'll just use this as the example. In this case, we're going to set up on the track for fabricate. So if you remember back on the original slide, there were 3 tracks. The first one was fabricate, transport, and then the last one was install. So you actually set up your progress item or your step, and then the index of that step. So in this case, cutting was the very first thing you do for fabrication, and that progress phase is fabricate. So you can easily set up the sequence of it, as well as that progress track. Now, the other thing you can do with it is set up as a group, and then determine what the progress weight of that group should be. So for the group overall, for fabrication, your progress for fabrication is 25% of the total progress. So a fabrication is 25%. Your installation may be 50%, where your transport would be 25%. So you have the option of setting progress weighting for each track to get an overall weighted progress for the item. So once you've set up all of your parameters, this is essentially what it's going to look like when it comes out in terms of the progress tracks. So your fabricate, here's your first track, and it has, if you remember, cutting was the level 1 step. Okay, and we set up 75% for fabrication, so cutting, welding, and then for testing that pipe spool, we set up 25% weighted earned value for NDT testing and quality control. On the transport side, you can get earned value for receiving on site, getting into storage, and then issuing it to the work phase. And the same with installation. 3 steps were set up for installation, for rigging, bolting, and then testing it for commissioning in the plant. Okay, so I hope all that seems pretty straightforward. The next thing you want to do for step 6 here is really set up your RFID and barcode tagging procedures. So once you set up your basic progressing, the next step really here is making sure you've got the right tagging procedures. If you're tagging the item with barcode, tagging with passive RFID, tagging with active RFID, or tagging with GPS. So you do have a wide variety of different types of sensor tags that you could use to set up those tagging procedures. In this case, in the photo, there's actually an active RFID tag on a valve, and in this example, this is the handheld screen. You set up an RFID tag ID number or barcode number, and that gets assigned to the item's identification. You can also set up a group identification. This can come back to a field installation work package, a construction work package, or even a construction work area as well. So it's really the parent. What is the parent of the item that's being tracked? So in this case, the description for this item is a valve, and it's going to go on module 1500. The other benefit of the system is that if you are doing tagging procedures at your vendor locations, you can also have them geotag the item as well. And so what that means is that you know exactly where the item was tagged, and if it has been tagged, you can set up procedures as well for knowing in terms of alerts, notifications that the item is ready to be shipped to your site or to your staging areas. So it's very, very flexible in that way in terms of being able to set up tagging procedures with virtually any type of sensor tag. The other interesting thing here that we do is you can also have photos as well with each of the assigned tags. And so let's say you want a historical perspective on fabrication of an item, or you're looking to see what the item looks like so the field knows what they're looking at when they receive it or when they go to locate it in the field. You can add just a photo to that so that it becomes more evident to the user about what they're looking for. You can also add in ISO drawings as well into the photo area as well. So if you're looking for line drawings or any CAD drawings, you can do that as well to understand the engineering requirements of the piece. So once you have your receiving procedures in place, the next thing you're going to do is really set up your system to be able to receive purchase orders at your site. So with that, I had mentioned before that we have receiving modules within SiteSense that can operate on those ruggedized handhelds to be able to pick off advanced shipment notifications or POs and then receive each of those items from that PO. And so in this case here, what I'm showing is a module we call Receive It. And in this case, it picks up all of the POs and ASNs that are expected to be received over the next few days. You can highlight that shipment to be received. And then from that shipment here on the right-hand side, you can see all of the parts associated with that shipment. So in this case, you've got some PSVs, some control valves, and a few other things. So you can actually select that item to be received right on the spot, make sure the quantities match, and then if there is no S&D, you can select that as well to add OS&D notes right in the field. And then once you're done with that, it's just a matter of syncing your handheld over Wi-Fi or cellular. That'll go back to your material management system to update your material management system automatically. One thing you'll also notice here on the bottom is there's also a Tag It button. So Tag It allows you to, if the item has not been tagged at the vendor location and you want to tag the item right at the project site, so you can control it on the project site, you can tag it right there on the spot with an active RFID tag, a passive tag, barcode, or even a GPS tag to track it around the site as well. So that allows flexibility in terms of having your vendors, your fabricators, or any of your suppliers tag your goods before they get to site, but also allows you any of the corner cases that may come to site to be able to tag them right when they get to site. So once you've received your materials on site, the next thing that you need to do is be able to update your material locations on the project site. And so there are a number of different methods to updating your locations of your materials and equipment. I've listed some of those options down here, and we'll talk about each one of those. But essentially, if you're doing progress steps based on material movement, so based on, let's say, going into storage or being moved to the work phase for staging progress, let's say, then you may want to use location updates as your automated method for progressing. And so with that, you can have a couple different options for being able to update tag locations. You can use Rover, and this is our patented system of using an installed RFID system into a vehicle. So this is the one that goes into the loaders or the zoom booms or the skid steers that operates in the background of the operator. And as they drive around, your tag positions are continually being updated many, many, many times a day. And so with that, that gives you the best performance of using active RFID to understand material movement and when they enter the new zones for those progress steps. The other option is a handheld cycle count. So if you want to physically walk or drive around your site, you can use one of the handhelds with the RFID reader, and from there it's more about covering the areas you want on your project site that may not get covered by a rover, let's say. And so from there you can go through the material laydown yards, go through C-cams or warehouses, kind of whatever you need to do your cycle counts. And so if you're using active RFID as your technology to update your spool locations or your structural beams or your mechanical equipment, then it's just a matter of making sure you get the right coverage area for that. And what we found for a site with about, let's say, 15,000 tagged items over about 100 acres, that can take about 45 minutes to get complete area coverage to update every tag on site. So that's still pretty fast for being able to read 15,000 items over an entire site. And then your next method, so let's say you're using passive RFID or barcode. In that case, every time you move material, you'll actually need to scan it, rescan it when it moves to a new location. And then that scan position gets geolocated for that new location. That's a little bit more manual intensive than using an active RFID or GPS technology, but still gives you the same result. You just have to be more methodical about being able to scan your tags and updating the locations. Now the best of the best really is GPS, and so if you have a GPS tracking tag, that GPS tracking tag actually provides you automated updates of location at an interval that's preset at time of shipment, which could be once an hour, once a day, once a week. It's really set up at the time the contract is written in terms of how many updates is seen from that GPS device. So let's say you have a module, a pipe rack module moving into place. You may want to track that with GPS to know when it arrives on site for getting your rigging crew set up, and then when it moves into location for installation as well. And so GPS can be an effective tool for in-transit tracking as well as installation as well, to know that if it's your vessel or your module that it's been rigged into place. And this little screen down here, what you're seeing here is just a GPS tracking screen of it was a barge shipment that we tracked that went down the west coast through Oregon, up the Columbia River, and then from there it actually went on a truck where it was transported through Idaho. And you can see here that in this case, the driver actually turned north a little too soon, and they used our technology to be in direct communication with the driver to get him turned around to come back so that he could get through the mountain pass and get him on time to his destination. So using GPS can be very effective in real-time shipment as well for any of your expedited components. So step 9 is really being able to find those items that require progressing to get the earned value progress reports completed. In this case, we have a graphical pick list that can be printed out from SiteSense or found on the mobile device. In this case here, the barcodes you're seeing, these are the barcodes of the RFID tags themselves. The handheld can actually scan these in the field and bring up the location of where these items are. That helps the workers get to the material location very, very fast. They can also use a printed out map as well and be able to route themselves from one item to the next. And so with this, there are a number of options here to being able to find those items that require progress to be done on them. You can use the website to look up location of items. If you're in the field, you can use the handheld. Or if it's integrated directly into your MMS system, then you can look at your system to look at the latest zone location or lay down location of where that item may be, or where it is in terms of its rigged in location as well. So a number of options you have for being able to locate that item. Once you've located that item that needs to be progressed, it's as simple as scanning it with the handheld and performing the work right there on the handheld, or updating the progress of that item. In this case here, in the track it module, the item we scanned, is control valves, and then you can actually see the milestone tracks that had already been completed. So you know when it was shipped, you know when it was received on site, you know when it was staged in the work area to be installed. And then in this case, we're going to actually set the installation date on it. So these progress tracks automatically trigger the events in SiteSense and in your material management system if there's integration completed for that, to be able to update the progress step for that item to drive through your earned value system. So this is, again, the steps here are set up on the website, the steps that I showed earlier, in terms of being able to set up your handheld to match those progress tracks that you set up earlier. Okay, now let's say everything's going really well, and for some reason you can't make it to the project site today, and so you want to actually view that status remotely. This is where the cameras come into play. If you have cameras located around your project site, these are IP-based cameras, the remote control pan, tilt, zoom cameras. You can actually use the cameras to zoom into the location of that material or where it's being rigged into place. And so from there you can actually get real-time video streaming of the site, and you can zoom in and out of different areas to monitor that progress. So this has been a very effective tool for our clients in being able to monitor remote sites without having to fly to site or drive to site, and if they're just looking for something quick to understand progress. One of your final steps here is viewing your progress reports. So this screen here on the left is really just another representation of progressing for, in this case, it's structural steel. But that also goes back into a progressing scheduling system as well, to be able to update Primavera as an example. The other component that we have as well is being able to integrate those progress steps back into your earned value system. So this is an example of an S-curve that's come directly from a client tool that we've integrated with in terms of being able to get your earned value progress over time using your RFID technology for material movement progress and your mobile device for field progress. Just to sum up a few of the benefits of the system, using the new technologies, RFID and mobile devices in the field. Independent sites have been doing this with CII is one of those, where they found it's about 8 times faster to locate items in the field using active RFID technology. And just considering that amount, a tracking system can pay for itself many times over just through the efficiency gain in being able to locate your materials in an expedited fashion. With progressing, on the progressing side, being able to progress in the field and directly reflect that on your reporting systems allows you to do closer to real-time progressing. And what that really means is that the contractor is going to get paid faster for work complete. All right, so instead of being a couple days behind on their earned value reports or even weeks behind, you can essentially be updating your reports in close to real time. It's also got traceability on who's done the progressing. So every time you log into a mobile device, we know who the user is, and in that case, we're logging all events by each user. And so if you're ever questioning who may have progressed an item, you always have the information of who actually did it. You can go back and audit that progressing. And the other big component here is integration with existing systems. So if you still want to continue to use your existing systems for earned value or for progressing or material management systems, then really that's what we've developed our system around is for you to be able to do that, keep those systems, but still use the best of the best technology to really enhance your receiving, your materials management, and your progressing systems that are already in place today. So Nicole, at that point, I'm going to pass it over to you for any questions that have come through.
Okay. Thank you so much, Dale. For those of you who might have joined late, please use the questions tab on the toolbar. Those will go directly to me, and we can get some questions answered here with Dale on what you've seen. Thanks, Dale. One question here is, what equipment or services are you using for on-site cameras? Maybe just explanation on how that integrates.
So is the question, Nicole, what is the hardware, or what is the?
Well, these are typed in questions, so unfortunately I can't get a lot of clarification, but maybe if you could just talk a little bit about the cameras.
Sure. So yeah, let me expand on the cameras. So the cameras that we integrate with are Sony IntellaWave cameras, and so these are IP-based cameras. Now we can actually integrate with virtually any IP camera. You know, in the past we've chosen to use Sony cameras just because they've operated so well in the cold weather environments. They actually come with built-in heaters, and we've been able to operate them down to -40, -50 Celsius from an ongoing basis. They've required, if I understand the other part of the question, is service. And so we've had cameras that have been installed for more than 5 years now at client sites, and we have not had to service a camera once in terms of it going down or having to clean it. Let's say the clear dome bubble. They operate themselves, I'd say, for many, many years. You just want to make sure that your installation procedures follow what we have on our installation procedures. That's what the big thing. As long as installation and all that is followed, then really you're going to get a lot of useful life out of the cameras. The other thing I'll mention about the cameras, Nicole, is the zoom in for the cameras. These are optically zooming cameras. All right, so the way we can stream them really well is because they really are a VGA camera, but what we have is a high optical zoom or multiplier. So with the Sony cameras as an example, these are 26 times zoom, all right, which allows you to zoom in pretty close up to an object, let's say 200 meters away. Let's say you, as an example, a license plate on a truck. If it's 200 meters from the camera, you can easily read the license plate numbers on a truck to give you an indication of how powerful the zoom factor is. The other piece with the cameras is that once you're logged into the cameras as a user, and these are user privileges as well, so we have it set up so that only certain users can have access to cameras depending on their roles and privileges in the system. But the user can actually take photos or snapshots of what they're seeing as well. So let's say there's a safety infraction on site. They can log into the camera, take a quick snapshot of that safety infraction as well as part of the history. The other cool thing you can do with the cameras is we can set them up to take pictures routinely. Let's say you want a picture twice a day of a building going up. You can easily do that to set it up to take multiple pictures every day. So you have historical progressing of your buildings day over day.
Great. Thanks, Dale. Lots of questions just came in. So I was afraid. I didn't know how we were going to fill those 10 minutes. But here we go. What versions of Windows mobile platforms are supported? 6.5, 7, 8, question mark.
Sure. So right now on our commercial versions of the Windows mobile operating software, it's a 6.1 is what we use for the Trimble, Intermec, and Motorola devices. And then we also use Windows Mobile 6.5 for some of the newer smartphones and other devices. As an example, the Juniper Mesa is a Windows 6.5 device. We haven't yet tested a Windows 7 device, but we will be shortly, as well as the latest in the Android operating systems.
Great, thanks. Can I use SiteSense as a standalone progressing system?
Yeah, the answer is 100% yes. If you don't have a tool today and are looking for a tool, we've built it so that you can report back using SiteSense reporting. So the answer is definitely yes. But if you have your own progressing system, that can also be integrated with Nicole.
Okay. This question's about cost, but I mean, really, their question is the cost, the differentials between GPS and active systems versus passive RFID, and also, like, what is the time involved to deploy the systems with all the readers? I mean, in general terms, I mean, I'm assuming a lot of this would be based on scope of the project and the like, and specific questions on cost, you can follow up, obviously let's follow up with those separately offline, but if you can just talk about the differences between the two a little bit, that would be great.
Yeah, for sure. No, that's a pretty broad question, in terms of how long it takes and stuff like that. Nicole, you're exactly right. It really depends on the project scope. We can deploy systems within a matter of days if it's a small enough scope. The larger scope projects can take many months to plan out ahead of time. So that really depends on the size of your project. I'll just give you an example. We deployed a system within a week here just this month. It was for a few hundred tags, and they want to track their equipment around their project site. And so stuff like that can be set really very quickly. But if you want to have in-depth integration with your existing systems, for progressing or for material management systems, then yeah, planning of a system like that can take many months. In terms of deploying the infrastructure, it's really the planning that takes the longest time to make sure you've got the right components set up.
Well, that's great, because the next question dovetails that, and it says, what is the average training time required to get a project site team up to speed with the software and hardware? I guess kind of starting from a baseline of 0, having never used the technology before.
Yeah, and so that, I can answer that question as well, Nicole. In terms of training on the system, if it's a small scope project, then we can train a team in about 4 hours how to use the tools. If it's a more complex project, we've had to do training up to about 2 weeks over time, and that requires some ongoing training as well. If the users don't quite get it the first few training rounds, we offer ongoing training over the next few months, as well as site support as well. And that's one of the things that we do as a company, is we provide professional services, which can be for a month or 2 months or 3 months, really to integrate the tools with your material teams. To be a successful project, you really need to make sure that the new procedures are followed, the technologies are performing the way they should. And so in that case, for your most successful projects, you really want IntellaWave or someone like IntellaWave to be involved in your project on a daily basis while you're ramping up on the technology. And those are more for the more advanced projects, the multi-billion-dollar type capital projects. For the smaller projects, we've been able to support those on a lower level basis, where it's more phone and email support, with maybe 1 or 2 trips to site to really get the end users trained on the system. And the other question there, Nicole, in there that I didn't answer was kind of the price differences between the different sensor technologies, and they really can vary a lot. And what I would like to say, whoever asked that question, is contact me directly, and we can walk you through the different technologies, kind of what they cost from a tag perspective, and then a support perspective as well. Just as an example, GPS, uses satellite communications to communicate positions back, and so it actually requires a service agreement, with the satellite companies to be able to do something like that. So that there are a lot of factors that go into, well, what does it actually cost per tag? And in some cases, not as quite as easy or clean cut in those costs.
Okay, thank you. Have any of your clients used this to tie into maintenance activities? Good
question. Yes, the answer to that is yes as well. That was actually one of the first things we did as a company, was build a maintenance tracking system into SiteSense, so that the users could scan the item, and then through the sort of a similar progressing scheme for construction is your progress track. In this case, is really a maintenance track. So you can scan the item, press the maintenance button, and in that case, the maintenance date gets updated, who the user was, who updated it, et cetera. And then we provide reports back to the users on what equipment was maintained, what's coming due for maintenance, and then what's overdue for maintenance. So that was one of our early deployments, I would say, in 2009, and that was in an operating refinery in the U.S. to do that for that client. So the answer is definitely yes. RFID is a great technology for maintenance systems.
Okay, great. We also had a question here about where folks can get the link. So I just wanted to show it on my screen. And I have 2 monitors. So can you tell me what screen you're seeing, Dale? Probably my desktop.
Looks like some canyons or something, yeah.
That would be the wrong one. Okay. So here perhaps you all can see the FIATech website. This will be posted, like I said, in a couple of days. If you go up under events here at the top, then click on webinars and drill down to the 2013 webinars. This is where you'll be able to download this presentation. If you just give us a couple of days, we'll need to package it and we'll post it right there. Back to some more technical questions. How accurate can a GPS tracking be if you move the material from one staging area to a construction area, which is fairly close to the staging area? Can the GPS detect such movement between two adjacent areas?
Okay, good question. So I'll relate. Yeah, totally, 100%. Yeah, I'll relate it back to the sensor technology first, because it's different for each technology, because it really depends on a few factors. So let's say you're using barcode as the simplest technology, and you're scanning the item as it goes from the laydown, and you scan it again when it goes to the staging area. In that case, your GPS position for that material is based on the accuracy of your GPS device, which in this case, if it's, let's say, a Trimble handheld or a Juniper handheld, can be about plus or minus 3 meters from where it actually is. That's the first accuracy. That also applies to passive RFID. If you're scanning the passive RFID tag with your mobile device and you're really doing a geolocate on it or a geotag on it, then again, that's about plus or minus 3 meters. If you're using an active RFID technology, because in this case we're using RFID as well to triangulate the position of the RFID tag based on movement, then you have to add in that inaccuracy to the calculation as well. And so in that case, your GPS accuracy, if it's plus or minus 3 meters, you need to add on your RFID inaccuracy on top of that. So in that case, about 10 meters is the movement. So if your piece has not moved, let's say out of 10 meters, then typically we won't reestablish a movement for it. But if it has moved beyond that 10-meter mark, then we will make sure that item has been moved in the system. If it's a GPS tracking tag, that kind of is the same performance as you would see with the scanning with the mobile device, because those GPS tracking tags provide about plus or minus 3 meters accuracy on position. So it all comes back to what's your procedure for updating the location of these items? Is it barcode? Is it active RFID? Or is it GPS? And then you can go from there.
Great, thank you. What kind of data is stored on the tags? Is it purely identification data, or is there all the previous history data, dates, etc.?
Sure. So good question. In this case, the system that we've developed is really based on a database. And so on the tag itself, all we keep is the unique identifier for the RFID tag. And that actually allows your system to be secure as well. And so you actually need the right device to access the material and the attributes associated with that material. So let's say your tag number is 111. If you scan that tag, it means nothing to somebody without the right type of device. If you do have the right type of device, then you can actually go in and look at all the different attributes. What's the line item number? What's the weight of it? When was it last maintained? And also the history of it, of where it's been in the material movement of it. So when was it last in the laydown yard? When was it fabricated, and so on. So all that can be accessed through the SiteSense mobile device database that is a simple to use user form actually that's easy to use. And the same information is located on the website as well. So if they're not in the field and they want to look at specifics on an item, maybe where it's been in the last 10 days, especially if you're tracking equipment like welding machines or generators, you want to know if that piece is being utilized or not, if it's most efficient of what it's doing. You can easily go back and say, oh, last 10 days it's moved around into different construction work areas, and yes, it's being used for the right purpose or what have you. Or you also know that its material is being moved too often, which is also a problem in the construction industry, is that every time you touch material, it gets very expensive, obviously, depending on the labor rates and your construction equipment rates. So you do want to only make sure you touch material once laid on yard, once you get there, and then the next time to really bring it to the staging area to be installed. So you can track performance that way as well.
Thanks, Dale. A couple more questions here, and then we'll wrap up. Is the technology intrinsically safe? Are the devices intrinsically safe? And are the sensor tags certified to be used in hazardous zones or hazardous areas, such as Zone 1, Zone 2, et cetera?
Okay. So the answer is yes. Depending on the technology, there are different variations of the intrinsically safe certification. So with active RFID, you can get an ATEX zone rated 1 certification for readers and tags. The same with passive RFID as well. There are Class 1, Division 1 ratings for both tags and handheld devices. And then some other RFID tags are also rated for a Zone 2 as well. So it really depends, Nicole, on the rating of the area where the equipment's going to be used. And then from there, we would just specify the system that the user would need to be able to do that.
Okay, 2 more questions and then we'll wrap up. How do the cameras communicate and to where?
Sure, so the cameras communicate, they're Internet Protocol cameras, so they communicate directly over a web protocol. So in order to do that, you have 1 of 2 options. You can run wired Ethernet directly to the camera, and you just run it back into a switch somewhere to do that. And typically we run our cameras through a port that's Internet accessible, but you can only access that camera through web-based privileges and logins. The other way, if you don't have, or if you're not able to use wired Ethernet, you can also set up a wireless access point right by the camera to stream that data back to another router or a switch in the area to be able to receive that signal. So the bandwidth required is not that high, just because they're VGA cameras. So you can still do about a 20 frame per second type system and get streaming video through wired or wireless infrastructure.
Great. Okay, and last question. Have you had any experience tying this to additional document management systems, such as tying a material location to a specific material data sheet?
So for that question, we have built into SiteSense being able to add documents to the item. It can be actually on a progress track. You can add a document. So let's say for example you have a rigging document that the crew needs on site. You can actually add rigging documentation if it's weights and balances or what have you. And so because it is a web-based system, that allows the riggers to be able to go and download that weighting documentation or orientation documentation right from the SiteSense progressing website. But if I understand the question correctly, I think it's more related to, can we pull documents into SiteSense, or can we push documents into the documentation system? So if it's SharePoint or another system, the answer is definitely yes. We've done document sharing before with SharePoint and within our own tool. So it really depends on what the requirements are and what the tool is and kind of what the end goal is. But definitely the answer would be yes, Nicole.
Okay, great. Well, thank you so much. For those of you who sent in questions and we ran out of time, please know that we will be forwarding that info to Dale, and they'll be following up with you privately. So thanks again for taking the time, Dale, to share with us what you all are doing. And everyone, have a great day.
Thanks, Nicole.